And again, I see the signs.
This is Song of Bloom, a beautifully handcrafted game. This collection of mesmerizing puzzles not only presents a delightful experience for the players, but they also offer us, React Native developers, a fun challenge as we work our way on how to implement them using Skia. So, let's play. Guys, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this video, we are looking at a beautiful game, Song of Bloom, which won the Apple Design Award back in 2020. And this game has been developed by an incredible indie maker in Germany, Philipp Stollenmayer. And for this tutorial, I've selected two puzzles from the game. The first one is this Mondrian scratch effect, so I can pass my finger through the heart. And so we get this nice realistic paper scratch effect. And we use path operations to create the path depending on the gesture, and then noise plus an inner shadow to get this realistic paper scratch effect. On every touch event, we add a circle to the path using the union operator. And we can express a circle using lines. We divide the 360 degrees, which are 2 times pi in radians, of the circle into pieces. It can be 4, 10, 20, you decide. For each angle, we get the position of the points onto the circle using trigonometry. The x-axis is the cosine of the angle, and the y-axis is the sine of the angle. The more we divide, the better resolution we will have. Once we express our circle using lines, we can use noise to deform the points in an organic manner. A noise generates a value between -1 and 1, and we can play with the amplitude and frequency parameter to achieve the desired effect. And we can add an inner shadow to the path to finalize the effect. The second puzzle is a nice homage to the Banksy shredded heart, so I can shred the heart like this. And so the painting is represented using vertices, and we use noise to deform the vertices. And using texture mapping, it gives this sense of paper stripes floating in the air. And I can translate, pass my finger through the heart, and then up, it drops nicely. We represent a rectangle as a series of triangles. You decide how many triangles you want. And using vertices, you can map a texture to these triangles. From there, we can deform each point using a noise. Here, we will use 2 inputs for the noise, the index of the point, and time as a second parameter. Again, we can tweak the amplitude and frequency of the noise to achieve the desired effect. So what do you guys think? Can it be done in React Native? Let's have a look. So we are into VS Code here, and I have a boilerplate project which you can download from the video description in case you want to code along. And I'm loading Skia Canva, and I'm displaying the background image here, which you can see. And I'm also loading a second image called mask.png, which is just the same image, but just with the black line, which we're going to add on top of the effect. And in fact, I can even display it directly here. And I think the first step is that we're going to add the gesture and draw a circle, draw the path that the finger draws. So I'm going to create an animation value, which is going to be a Skia path. So I can use value from Skia. Let's see. And the default value is an empty Skia path. And we're going to need to add a touch handler, so on touch. So we're going to create on touch, use touch handler, and we can pass a touch handler here. And what we can do maybe is on active. So we get the position. So what we want to do is to assign a new path. So path.current equals, and here we're going to use path ops. So path, make from operator. The first path is the current path. Then we're going to create a new path and we're going to draw a circle with the center being the position of the finger, and the path up is union. That's almost correct. Let me import it. Union. So path here. And this, I think we can make it, remove the null. And let's draw the path. So path equals path, color white. Let's have a look. Yeah, looks good. And so we have the draw circle, which simply creates a path and add a circle, but we know that we need to make it draw lines and add some noise, but so you see if I remove, by the way, the mask.png, this is how it looks like. And then if I add it on top, the black lines are overlaying the Canva. Maybe let's add some inner shadows. So I can do shadow dx dy 0, color black, blur maybe 3, and inner true, and I probably need to add some opacity to the black color. Yes, maybe diminish the blur even, and here use something like this maybe. Yeah, I like it. All right, so here let's decide on a number of points we want to draw. So let's say maybe 4 to start. So we create a path, and yeah, so for each point we get the coordinate on the circle. So let's see. I feel, is this correct? Yeah, I think that actually looks quite okay. And actually and here we have a square, right? Because we have 4 points, and we can add 10 here. And if I have 20, maybe it should almost look like a perfect circle. Yes. So the angle here, let me extract it. So we have theta here. So here the code was generated by Copilot, but we know that the x coordinate is the cosine, y is the sine, we multiply by radius, and we translate by the center. So, and then if it's the first index, we do a move to, if not, we do a line to. So this looks correct. And maybe I can create toe here, even put it outside. So here this was like given to us by Copilot, but this is very, I would say, sensible. So now let's add some noise. So let's create a noise. So we need only one noise dimension, but we're going to use, so the minimum we can have is noise 2D, but we're going to just pass 0 as a second parameter, a constant value. So noise equals create noise 2D. That's good. And so we're going to create a delta, and we're going to have, so amplitude A times noise, frequency times T. Yeah, T is good, or theta. Theta is good as well. I guess this one is good. So the amplitude by how much, right? So if we go from -1 to 1, and we have amplitude, let's say that is 5, it's going to go from -5 to 5. And then frequency, let's try with 1. So the amplitude looks, or either this, oh no, yes, so nothing worked. So then we can add the delta to the values. Up. And we could create a different noise for X and Y, but it's not going to be necessary here, I think. So let's see now if I put a huge amplitude. Yeah. So here you see we go from -50 to 50. The frequency seems to be, so maybe here 20. And what if we increase? I mean, that's not bad, but we need to increase the frequency, right? Yes, here it's almost too strong. But we can play with these values and you see until we get a desired effect. This is nice. 3 maybe. But you can tweak these parameters to your liking, but a really fun usage of the noise. And now for the second puzzle, we're going to look at noise, but in the context of vertices. So here in the boilerplate, I have a couple of things already. So I have the touch handler so I can move the image around, which we display as an image shader, which we use as a shader of the vertices, which are in the stripe element. So we divided this image into this number of columns, right? These stripes, which you see here. And if we go into the stripe, it's simply a vertices. So we divide the column into triangles, which this component helps us debug. So we print here in black, so I can remove it here. So here it looks like a perfect rectangle, but we're going to deform it. And we use this to debug it. But, oops, let's... so we have this function, generate triangles, points, and indices. So we generate all the points. So for all the points in the column, same for the texture, and then the indices. So for each point, we give the corresponding point to the texture. And this is what is used for the texture mapping. And then to not repeat the number of points when we give the triangles, we just give the index in the vertices to give the list of triangles. Here as a parameter, we give the number of triangles we want to divide the 8. So for one column, in the width, we have only one triangle, but then we divide by a certain number of triangles on the height. In fact, let me change this parameter. Here we have 20, but it can be 4. You see, we have only 4 triangles per column. I mean 8, but it can be 2. So we decide 10, 20. Yeah, so here we generate the data we need to use. So that gives us vertices, indices, textures, which we can feed directly into vertices. And here we use this to debug. But let's start maybe first we need to apply a background, a frame on top. In fact, we have these images here. Let's see. So we have the background image. And do I have a rectangle for the background? So here we have a rectangle to display the frame in front. Doesn't look like it. So which parameters? I guess picture. Yes, I guess that's what let's see if I use picture here, maybe. Okay, looks good. And we can add the frame on top of it. So outside the transform, where is the transform? Here. Okay. So here would be frame, and we have frame rec. Okay. And Also, what we want to do is to not be able to go up. So here we can simply check if the new y is greater than the y.current. Only then. So now I cannot go up anymore. And maybe one thing I want to do is that if I'm going outside the frame, it needs to drop down. But I see here also I have an issue with the position of the background. Oh, I can simply do fit cover. Okay. And here I want to drop. So if y.current or e.y is greater than so picture reg.y plus picture 8. Yeah, we can do a run timing on y to go to, let's say, screen height. Let's see. Yes, and we maybe can make it go faster. Okay. So that looks good. Now, let's do the deformation so it's clear to see what's happening. We get a clock here as parameter, and we can use it to deform the vertices. So we're going to map, and we're going to create a noise here, and here we really need a noise 2D. We're going to use the two dimensions of the noise. So we get a vertex and an index. So we want to create a delta, which is going to be, so first we can use, and we're going to have a frequency and amplitude, right? So let's say 1 for now, or maybe let's put, I don't know, 10 pixels. And f, we can put 1. So f, so a times f, and here I'm going to use the index divided by, so as a rule of thumb, I like to have here a value that goes from, I mean, it's a bit silly what I was, let's see, I'm going to take the index. I wanted to say that I like to have a value that goes from 0 to 1. Gives more control over the frequency, but here we're going to use the clock value as well directly, so it does not really make sense, but we need to do f times clock.current. And we can return, so the vertex, the deformed vertex. So it's nicely deformed. In fact, let me put it back to 0 here. One thing I want to do also maybe is to have the stripe separated anyways. So should I add like something like maybe 5 pixels? No. Let me see. So should we add here? Or remove to the stripe width? Yeah. So we want to separate them nicely. Add some noise. Nice. So here the frequency is really high. So I think first here we create the noise every time, so I will need to, I'm going to put it here outside. Let me just reload the effect. That doesn't look too good. I think we probably need some. So here I'm going to use index divided by vertices.length. Maybe we can add some, so maybe let's call this one fy. And here we can do fx. Let's play with fx to see if we can. That's actually somewhat better. And should I even actually something like this? That's actually not too bad, right? And now we need to overlay the image when we're within the frame. Okay, maybe I can call this one I. So we're going to need to overlay this one and clipping it. So, but instead it's an image. And okay, we can just repeat these, even though I guess I could just put these directly here, here, close the group. Looks good. And now we need to clip this one. So I need to put here, I need to put an outer group because we don't want the clipping to be affected by the transformation. And I'm going to simply clip by picture rec. Let's see. So that looks good. The clipping can be slightly refined. And in fact, I think I want here maybe to add 10 or 20, 10 to the translation so we don't see the top. And we can also improve the clipping here. So we can do .y, .width, and for the height we can remove maybe 10. Okay, so now that looks good. And one thing we can do is that when we drop, we can increase the amplitude and frequency. So maybe I can create amplitude value and default. Since we multiply, we want to keep 1. And here, if we drop, we can do run timing on amplitude to go, let's say, from 1 to 2. We multiply by 2 or 3. And I'm thinking, yeah, should be good. Let's see. And we can pass this value to the component. So you can have amplitude is a skew value. And we can add amplitude.value.current. So let's see. That didn't. I didn't see anything here. Let's see. So if I drop, that was not really obvious. Let me check here. So if we put a huge value, maybe, let's say 20 just to debug. Yes, okay. So maybe 10. Okay, that looks good. So if I drop, I think that's okay. One thing I want to do here is not look at the end position, but at the current translation. Because now if my finger is outside, it's going to drop the painting anyways. And also here you see I can pass my finger through the stripes, and I want maybe to increase the noise frequency, so as if I was really touching the stripes. When my finger goes over it. So I want to create an animation value for the current stripe we're touching and what was the previous stripe we were touching, to see if we switched the finger from one stripe to the other, and trigger an animation that will make the stripe shake. And we make it shake by increasing the frequency. So let's create these animation values. So current index, and we're going to take -1, and previous index, we're going to use -1. So on active, the previous index is the last index, is the current index, and the current index is, we do a round of so e.x minus picture rec.x divided by stripe width. That looks correct. But let's check, so we can pass these values to the stripe. So we have current index, which is also a scale value, and previous index. And here, so we're going to create an animation value, and I'm going to call it, since it's going to be like some frequency, I can call it f maybe. And here again, we want the default value to be 1. So if we switched index, so if it's a current index, the index is selected and we just switched, and current index.current is different from previous index.current, we start an animation. So we can do run timing on F, and we go, I don't know, 4, we multiply by 4. It's probably not correct, but, and maybe for a short duration, 250. And then when we end, we want to go back to quickly to 1. So maybe you can do run spring on F, and we go back to 1. Let's see. I think, let's see. Let's multiply maybe this. So f.current. So let's have a look. Yeah. So it lasts, 250 is way too long, it looks like. And 4 also is way too big, right? So maybe 2. Even 2 looks, what? I think, let me reload here. This is okay. I think maybe 3, and I think one thing I need to do here is when the gesture ends, we need to set, so previous index to -1 and current index to -1. Okay. So yeah, that's a bit too strong. Can do, I think maybe probably 2 is okay. It's very aggressive. I guess we had 1.5. Seems like it might have been okay, but I might. So let's have a look. Looks good. I pass my finger through. I can drop it. So pretty nice, but here you decide, right? These noise values, it's really a matter of taste. Guys, I hope you enjoyed this example, a really fun application of the noise first to do the scratch effect. So, and we use the Skia path operators to create one continuous path using the union operator. And then instead of drawing circles directly, we represented a circle using lines and used noise to deform the lines and the inner shadow to create this realistic scratch effect. And then we looked at vertices and texture mapping on vertices. So when we deform the vertices, but the texture mapping stays the same, we get this nice realistic effect of a paper stripe. And I think we can do a really cool stuff with these vertices and texture mapping. So I hope that it's a theme that we're going to explore in future tutorials. Let me know what you guys think in the comments below. I am looking forward to talk to you soon. And until next time, happy hacking.
Shine a light through a prism full spectrum. Pull the curtains back, you in my dimension. Lay back and just forget the people never make it out. I'm a 5-star brain in a 2-star town, and I'ma give it back when I have enough money in my hands, enough for the friends and the fam, and I owe it all to Yahweh. Lord knows that I couldn't do it my way. Almost bought a ticket for the fast lane. Now I'm hopping on a flight to the Everglades to forget the pressure.
Yeah, anyway, it's like super fast.
Wow.
Oh, wait, I need to get a ticket.
Oh, can you get me one also?
Yeah, sure.
Wait, show me that again.